course. Thanks so much for sharing and helping us contribute to the community.
Thank you. Thank you so much, Howard, for this, and happy to be here and happy to contribute. So I'm not going to take too much time. I think Howard already did a quick introduction, but yes, I mean, I am a data consultant for a couple of years now, and I'm an enthusiast around data and AI, and I have a couple of certifications around that. And I've been working in the region as a data consultant from data management governance, reaching up to the end of the pipeline in terms of analytics and the interesting, exciting part about data. Because when we're saying AI, and as you will see through the presentation, mostly it's about data. And I mean, it's built on top of data. So let me share my screen and give it a quick introduction. So basically today, what we're going to be talking about are a couple of topics, and I'll try to make it as interactive as possible. And I can see we have at least, I mean, around 30 people here. So it should be somehow interesting. So we start with some insights to give a little bit of credibility about all of this fuzz around AI and machine learning. What is it all about? And is it really has an impact as many are claiming? Then we'll move to an introduction, AI, machine learning. How did it start? The roots. Just to give a little bit of background and context about it. Then we'll jump to deep learning, a bit of, again, explaining in a non-technical way, what is it? What does it mean? Some of the techniques that are used, the applications of it. We move to the applications of generative AI. And then last but not least, we have to talk a little bit about the ethics and risk and considerations that one needs to look upon, especially if you are someone as a practitioner, and even as in terms of general knowledge, if you are part of an organization who is willing to adopt and move forward in an AI transformation journey. I think these are very important considerations to note. And finally, we jump to the AI organization, and we'll conclude with that. As organizations, where are we? Where do we stand? How can we become AI value creators? What does, we're hearing a lot of terminologies around AI governance and so on. So basically, I'll start with some insights, and I'll try to leave a little bit of time at the end for an open discussion. I'll be happy to answer your questions or comments. So I'll start with some numbers. I mean, this is a report published by McKinsey that it's based on a study that they have prepared, that the impact of generative AI to different use cases across multiple disciplines and industry is reaching up to 4.4 trillion US dollars. And I'm sharing these numbers just to give a little bit of a glance of the huge increase that this would bring to multiple industry, to the economy in general, regardless of the industry. And this is not only talking about IT industry, this is across multiple disciplines. And some numbers related to ChatGPT, which we all, like to use, and we're all maybe using on a daily basis nowadays. ChatGPT, when it was first launched, it reached, 100 million active users in only 2 months. And the impact it has on our productivity is remarkable. Again, we're talking about the fun and positive part of it. At the end, maybe we'll have a little bit of highlights on some of the ethics and risks that need to be considered. A report also by McKinsey showing the adoption of artificial intelligence in terms of multiple industries, ranging from professional services, retails, energy, financial, and overall in the Gulf region, which I'm working at, it's the adoption based on this survey is around 60%. And this is a bit more than a year ago when this was published. So now definitely this is increasing, and everybody's talking about AI. And we are going to tackle this during the presentation. And this is also showing, the top industries that are affected by, that are adopting AI, leveraging AI in their, day-to-day activities. It does not mean that the black dots below are not actually using, or AI cannot be leveraged in terms of use cases over there, but probably the adoption was a little bit slower, and it really depends on the industry itself. for example, sales, marketing. I mean, it goes without saying that these are definitely, they could immediately, and we see this on a daily basis in terms of advertising and how AI is really, straight to the point in terms of leveraging and scaling up these industries. Finally, the last chart I would like to share with you, and the reason I'm showing this is because I'm going to go back to it at the end of the presentation, which is in terms of AI, how our organization is dealing with it. And based on this, review by MIT, published a couple of years ago, but it still stands true, basically. Maybe the numbers have increased and changed, but companies were grouped in this study into like four categories: passives, experimenters, investigators, and pioneers. And it shows immediately that the companies that are considered pioneers are the ones who are really pushing the edge in terms of investing in AI and in terms of learning about AI. And when we're saying learning, we're talking about learning and development, which is some sort of an investment. But at the end of the day, investment in technology and in people. And this is what makes a company more adopting AI and definitely is going to have a better or faster pace in terms of the transformation. And we'll get back to this at the end. So enough of these numbers and introductions, and let's just jump quickly to it and maybe start with the basics. And bear with me a little bit, even if some of the questions might seem really basic, but bear with me and we'll try to think together, what does this all means. So I'll move maybe this, I'll share this with you. And I'm sure you are all technology adopters, and I think I'm confident that your mobile device is close to you. So if you could be kind and reach out to it, maybe scan this code and share your response to this question. For example, what makes a human intelligent? I hope, I mean, I'm sure your mobiles are close. I hope you're not using them during the presentation, but at least for now, please do scan the code and I'll be waiting for your responses. Maybe we'll give it a minute or two. What do you think makes a human intelligent? I mean, in terms of your, okay, thinking and thought. Very nice. Reasoning, learning. Great. Please, there are, by the way, it's anonymous, so please feel free. I mean, it's anonymous, you don't have to worry, and there are no right or wrong answers in this case. Reasoning, thinking, considering, ability to interpret data, being humble, very nice. Genes, very, very nice. Yeah, I mean, there is the IQ, perhaps it is genetic, but I'm sure it's not the only factor. Logical thinking, learning. So we have, I mean, I think the responses are pretty much close. Morality, that's a very important point here. This is where the emotional intelligence, I think, stands in. Everybody's talking about emotional intelligence and education. Okay, I'm happy with what I've seen so far, to be honest with you. And before, sharing my insights on that, I would maybe move to another aspect of it. Luck. Well, yeah, maybe. I might disagree a little bit on that in terms of making someone intelligent, but I mean, I appreciate here philosophical reasonability. Yeah. So let's jump to the other one, and then I'll give you my insights. But I mean, many of what you've just mentioned really interpret the idea of intelligent human, I mean, the intelligence of a human intelligence. Bear with me again, and please complete the sentence and just add your response. You have to scan, or you can maybe slide to the next question if you have this option, or you can just scan this again. I think on your mobile app, you might have the option to, or it will show maybe immediately this question. If you can be kind and complete the sentence. And again, I'm doing this for a purpose, just for us to give a little bit of context of what is AI about at the end of the day. So each morning I like to have orange juice, orange sun. Well, I think orange sun is during, sunset, if I'm not mistaken. Juice. So maybe we have, most of us would like to have breakfast, juice. Okay, fruits. Some interesting answers in here. But I think if we can see the word juice, most of the responses are around juice. But again, it doesn't mean that this is the only answer. I mean, you could have, but I mean, have orange breakfast. It does not, I mean, unless you want an orange as a breakfast. Yeah. Some of you are actually disregarding the word orange, probably. So just jumping to, I'd like to have breakfast, which is fine. I mean, it's just a matter of trying. But anyway, I wanted you to complete this again for a reason. Bear with me with one more, maybe simple and basic question. Many of my friends live in Orange. What do you think could land here? And again, it could be a lot of correct answers in here. I like some of the imagination that we have in here. County, houses, orange jumpsuits, life, suburbs, province. Very nice. Very nice. And I think, again, like juice over there, we have county here as the largest, maybe so far, the largest answer. I mean, the highest number of answers, or the participants added the word county. Perfect. Okay, so these were basic questions. Now, before really revealing what is the purpose of all of that and what we could really inspire for this, I'd like to end with this quick question. What makes a machine intelligent in your opinion? You have shared your answers about the humans, but what do you think makes a machine intelligent? We all have machines around us. Really, what does it make? Why do we say this is a smart phone or a smart computer or a smart application? Allow me here to say, okay, it's not about the functionality. What do you expect it to do? What makes it intelligence? Okay, in order for it to predict, because I can see the answer predicts. Okay, I can see the answer here. Okay, what helps it to be able to predict? That's the idea here, so that it is intelligent. I can see access to data, capacity, process, human brain, definitely. I mean, this is the number one factor. Otherwise, it wouldn't have existed. To be able to reason. Yeah, but this is the result, right? I mean, we might think that this is the result. The machine would be able to reason. This is the end result. But what makes it being able of reasoning at the end of the day? CPU power. That's a good one. Maybe access to data. Okay. Fine. I'm gonna maybe suffice with this and go back to my presentation. I'm still getting answers, but anyway, let me share my insights with you. So in terms of, it was defined by INSEAD, I mean, a while ago, that experience and learning makes a human intelligent. And we have seen that within the responses that you have shared. I mean, you shared education, you shared learning. I mean, yes, true. All of our experience throughout the past years is a factor of our intelligence. IQ is one of the factors. Genes are definitely a factor, but they're not the only factor. And the reason I shared this, and then I shared the questions, when I asked you about the orange and juice, what you did is that you leveraged your experience, your previous encounters, your data within the brain that you have, and you try to come up with words that would make sense. This is the generative nature of you as human beings, of all of us as human beings. And we did this in a fraction of a second. I mean, as you have noticed. It didn't really require that much effort to complete a sentence. What would I do? I mean, if I want to have an orange juice on breakfast. In terms of machines, big data, rather than experience, we call it big data, which replaces the experience. And then you have the machine learning, which is the learning process of the machine. This makes a machine intelligence or artificial intelligence. So I hope through this very simple example, I narrowed down the idea of what I'm trying to say here in terms of AI. And basically, these sentences that you have done, I mean, yes, juice and county are maybe the most appropriate or the most convenient two words to share in here. And what you did is leveraging, your brain power, and you did not really put a lot of efforts to do that. And I'm doing this, and I'm sharing this again to give a little bit of appreciation for us as human beings that we are still way ahead and way sophisticated. Even this very simple, straightforward, that some of you might say that this is a very silly task for the computer to mimic and do the same, such as ChatGPT. This required billions of dollars of investment and huge tons of data to be fed into this machine in order for it to reach a phase like ChatGPT, for example. When I asked him these questions, and it was able, sorry, to answer correctly. I'm going to speed up quickly for the sake of time and share with you. So, for example, when I asked him to share, I mean, I'd like to have an orange. He immediately said an orange juice, and he added a little bit of frosting, on in his answers, in a slice of toast and butter and jam. And then for the second one, he immediately knew that it's Orange County with known, and he added this as well. So for us, it's very straightforward. For the machine, it required a lot of investment, a lot of CPU power, as some of you have mentioned. And it is true. And this is only to appreciate where we are now and demystify a little bit the concept of AI, that we should not overrate it, at least at this stage. And I'll come to that maybe a little bit at the end. Now, just a quick overview of the history of AI. Okay, I mean, the journey of AI itself as a concept started from the 1940s and maybe even before in terms of the algorithms that were there, in terms of the mathematical algorithms, statistical modeling. They go way beyond the invention of any computer or any machine. But basically, I mean, I'm just giving some examples here. Again, there are a lot of other use cases that have been developed throughout the years, but I'd like to highlight some of the most common ones. So during World War II, I mean, if you've watched the movie, I think it's Imitation Game. This really shows what happened there and how Alan Turing invented a smart machine back then in order to break some of the codes, to crack some of the codes during World War II. The first industrial robot, and Shaky the robot, and you can Google these and find a little bit more about them. In 1995, 1998, the introduction of chatbots. I mean, I was still a school student back then. I mean, I was exposed to computer, but I mean, these maybe some of you would know that. Siri and IBM Watson, when we started, the jump of iPhone and the birth of IBM Watson as well. Alexa, the first robot, Sophia, the first robot, it had a citizenship as well. And eventually, ChatGPT, within the early 2020, 2021, we started hearing about this kind of automated human-like, applications. And this was in parallel to a technological revolution. So I just wanted to share with you that, I mean, in the 1990s, and why am I putting this in context? To explain why now it's booming, why it didn't boom before, why now the fuzz is bigger around AI and around data and all of that. It's really because there is an accompanying technology line going through all of this. So when we started with the ERP systems, when it was, the banking, account management and all of these very simple MS-DOS kind of ERPs back then, but all of these tools and solutions, they digested a lot of data. Then there was the rise of the internet, which also opened the door to a huge in and out data across the web. Then, the CRMs, like Salesforce, like others, and eventually the big data and cloud. And this was where, I mean, usually when the social media big bang started. I mean, really, it was then that when the revolution and the big data started to happen, and this was an enabler, and this allowed big companies to really start thinking how to leverage all of these, and we started witnessing how this is, growing and transforming as of then. But this is just to give you a little bit of an overview. Maybe some basic questions. I mean, really, this is something that conceptually we need to think about, and it will help us in defining what do we have in terms of AI. So at this stage now, all of us really, we are at the stage of what we call the narrow AI. So basically, we have observed an event X, or I don't know, something X. What do we expect to observe next? If you really think about it, this is what most of machine learning and AI solutions are doing. Okay, and this is all within the realm of narrow AI, and we have done some remarkable advancements here. However, another question to be asked in here, which is, what if we do X? What if we haven't done X? This is really more deep. And at this stage, still the machine, I mean, is not really, how can we say, there are not pretty much a lot of advancement in this area. And this is what we call the general AI. And to jump to the definitions, the artificial general intelligence is the actual idea of the complete, human cognition. Okay, but this very little progress, at least not to worry about. And you can really insert your favorite science fiction movie here. I mean, the idea of robots invading the world and taking over the world, this is really way far away, because this is the area where the complete cognition of a human cognition, sorry, of the machines, this is still very far, to be honest with you. However, in terms of the narrow intelligence, artificial narrow intelligence, it is basically asking the machine to do something, like classifying some kind of a classification task, fraud detection, I don't know, spam detection. This is what the machine is doing now, clustering, all of this. And we've done some remarkable, progress. So, anyway, so this is, again, just to reemphasize, this is where we are now. We are at the artificial and narrow intelligence. And in terms of science fiction movies and everything we watch on the, and the cinemas, it's still very far away. And even though very little progress have been done there, but nothing to really worry about. A little bit, let's go back to this. And since we're talking a lot about AI, machine learning and deep learning, and maybe it's a good time to ask this question that many of us still, maybe we hear a lot about these, but what is the actual relationship between them? So please feel free to share your answers. Again, it's anonymous, so even if you have it wrong. But what do you think the actual relationship, if there is a relationship between AI, machine learning, and deep learning? DL is deep learning, ML is machine learning. So we have, I think, one so far. Okay, we're getting more responses. I'll give it maybe half a minute or a minute.
Sorry, Wassim, there was a question by someone, hands up, should we wait till the end and then we can have those discussions?
Well, really, it depends. If it's something that could take time, then but I'm happy to take it now. I mean, as we're taking responses.
I think it was Kasim. You had your hand up.
Kamal, yeah, hi everyone. No, I'm sorry, I pressed the wrong button.
Okay, no worries, no worries. It happens to all of us. Okay, so as I can see quickly, and I'm gonna hide this maybe now. So basically, I think half of the audience that we have, I mean, here, they're saying that it's AI okay, as an overarching discipline maybe, and then there's a subset, the machine learning, and then there's the deep learning is a subset of the machine learning. This is half of the responses that we got. 15%, I have no idea, which is fair enough as well. Again, and many of the industries that do not really have an early adoption usually of technology, they don't really know the difference between these three terminologies. And this is why the purpose, I mean, of such presentations to have this closer. But I think fair enough, and AI, then deep learning and machine learning. So anyway, I think most of you guessed it right, and yes, it is the AI as the actual discipline, and the machine learning is a subset of the AI, and the deep learning is a subset of the machine learning. And if we want to look at the definitions, so the AI is the discipline. If you want to define it, what is AI? It's everything. When we say machine learning, this is AI. When we say deep learning, this is AI. But AI itself is the discipline, okay? The machine learning is the actual practice of the AI. The deep learning is the practice of, or the application of the AI. And machine learning is a system that trains the model from having an input data, and then you could take decisions or make predictions. And deep learning is a subset of machine learning to do more complex tasks using what we call neural networks, which we will explain again briefly without diving into a lot of technicals. Generative AI is a subset of of deep learning. So generative AI is one of the deep learning applications. So AI itself, as a big word, it's like the discipline. Like when we say data management, the data management is the overarching discipline, but then you have a lot of individual criteria of data management or components of data management, like quality, metadata, master data, et cetera, et cetera, et cetera. But they all under the realm of data management, if you want to imagine it this way. Let's start a little bit, Aman, how did it all start? And I hope this would relate a little bit and give you some context. Machine learning and AI in general, it all started eventually with statistics, and that's why many of statisticians now are working as data scientists, and it's not a coincidence. And one of the top on-demand, skills nowadays is statistics. So if you have a son or a daughter who are, going to university and they are appreciating these kind of skills, I mean, I would definitely encourage to dive into statistics. Here, I'm just taking an example of one of the statisticians. I mean, it was back in the 1800s. I think his name was Galton, and he did an exercise of gathering data in the UK, I'm assuming, of fathers and sons' height to answer a simple question: how tall will my offspring be? I mean, it's very simple. It's a very simple idea. I want to know really, if I get a newborn, how tall he will be when he's my age. And this really led to an idea of doing this kind of statistical modeling. And what I did here, I'm just projecting this. I got this data from a public data set, and it's Pearson data from Kaggle. And it's really a number of, I think, 800 or so fathers and son combinations, the height of the father and the height of the son. And then we asked the machine to create some kind of a best fit line that would help us, predict if we have a newborn. Based on his father's height, we would predict what would the son's height be. Definitely, there is no 100% correct answer, and I'm showing this to elaborate on this idea. And what we used to do, or what machine now does in terms of computational power, it's really about finding the best line, so that when you have a new data point, you could just leverage this line and see what would the actual height of the son be. And the idea behind it is to really narrow down the errors, or what we call the residuals here in the statistical terminology. So now with the ability to do this, I mean, before we used to do this manually, but now with the machine, computational power, this is something that is very much straightforward. In seconds, you can dump in the data and ask the machine to find the best fit line. Like we did in mathematics, it gives you an equation of a straight line. And then based on this equation, you could start predicting for new data. So the idea here based on Python, for example, I did this on Python, it gave me this line as the best fit with this small slight margin of potential, maybe possibility or error. But eventually, this is the best line if you want to model this relationship. So it all started with these basic questions, trying to find out about something, trying to figure out about something new or predicting something based on data that I have. And you can see a lot of applications in medicine, in healthcare, most of you have heard about. And going from there, we jump into really what is machine learning. And we have here two main types or common models for machine learning, which is supervised and unsupervised. And to briefly explain in a non-technical terminology, supervised is where we have, like the father and son's example, we have the data and it is labeled. We know what it is. We know what is that. And we dump it on the machine and we ask the machine to learn from it. Okay. And then we get new set of data and we apply this model on it. So we get the results and we know whether I want to classify if this picture is a cat or a dog, whether I want to classify if my wife will like the Christmas present, or whether I'm gonna, etc., etc., etc. You can think of many possibilities here. As of unsupervised, it's really the data is not labeled. We have the data, an abundant data, but we really do not have it labeled. We don't know really some patterns, and it's up to the machine to figure out patterns. And I'll show quick examples on that. So in terms of supervised, I'll show some quick examples of techniques with some use cases. But again, there are a lot more. And some of the techniques could work for supervised and unsupervised. It really depends on the use case that you want to apply. But for example, naive Bayes is one of the statistical methodologies that existed way long ago. But now we're applying this same statistic theorem onto the machine in order, for example, to segregate or categorize tweets. And this is what a lot of companies are doing. So they have training sentiment data, for example, it's labeled. So I have sentences and I label it. This is positive. This is negative. This is extremely negative. This is extremely positive. I label this hundreds or thousands of sentences and data, and I dump it into the machine as training data. And then the machine will come up with the test or the real data to give me, to immediately tell me that, okay, this comment from this user seems negative. You have to pay attention. This is a positive comment, and etc. So when it's really similar, when we see the training and testing data are really similar in terms of percentages, we know the machine is doing a good job in terms of predicting, but this is just to show some kind of an application for it. Another application of supervised machine learning is the decision tree algorithm. And many of us have used decision tree back in high school. And now it's being leveraged as one of the algorithms as well to predict. So for example, here, as you see, if you visited Kaggle as the platform, they have a competition that is very famous about what is the chances of survival on Titanic, and can we predict if, we had the ability back then to predict who had the bigger or higher chances of survival. So it's basically by doing, asking questions and going through the tree to finally to reach a leaf. And based on that, you get the numbers. For example, in this example, if you're not a male, if you're a female and not in third class, in upper classes, you have higher potential of survivors. And it is really based on the actual data that was extracted from the Titanic. The linear regression, this is something that this is like the example of fathers and sons. When you are trying to predict a number, I want to know how much, what would my sales, if I have a shop, what would my sales be, in this quarter or in this month, based on previous data. It could give me an idea. Similar to the linear regression, but when the data is binary, when you want to take a decision, for example, about a yes or a no, will your wife like the Christmas present? You want to know, is it yes or no? So here, if you look at it, it's a graph. It's still, we're talking about a chart, but the difference is that the data points are scattered between two values. So you cannot fit a straight line here. It will be, absurd. So that's why you fit a curve, a logistic curve here to give you a better kind of modeling. And again, I mean, it's a whole discussion for another time to really dive into these. But I mean, this is just to give you a little bit of food for thought. K-nearest neighbor is one of the famous algorithms as well within supervised. And basically, it's like classifying a new item based on similar other items. So this is why we call it, naive Bayes. K-nearest neighbor. And we jump to some of the examples on unsupervised. So what does it mean when we don't have labels? For example, clustering, customer segmentation. On Amazon, we have purchasing habits. So Amazon gets this data, okay? And based on the habits, without us telling Amazon that I like to buy, I don't know, technology items or headsets or microphones or whatever, it is able to cluster the customers based on the data that is available there. Association rules, again, for example, relationship between variables. When people go to the supermarket and they buy specific items together, and then the machine would realize that people who buy these 2 or 3 items are most likely going to buy another item, and so on. So yeah, this is another application. And dimensionality reduction, it's about, how can I say, finding hidden features within the existing features and trying to combine features into one. And I'll give an example to that later on. Some quick applications so that you would relate to it. I mean, we all know spam detection. I mean, we've all seen this, whether on our SMS, whether on our emails. I mean, it gives you these prompts, report dangerous, or it looks safe. And it's up to you to decide. Now, what Google is doing is taking our data, our response for free, and taking this, imagine the number of data they really accumulate on a daily basis. And based on that, what do they do? So again, just to narrow down the idea here, your feedback feeds the machine with labeled data. So then the machine, what does it do? The algorithm links it, for example, to the subject line, to the content, to the date, to the email address, etc., etc., etc. And then it comes up with a conclusion that whenever you get an email with 0 commission loans or free stuff or whatever, you immediately notice that Gmail has dumped this into spam folder without you asking for it. I mean, it's doing you a favor and relieving you. If you open your spam right now, you will get super surprised with the amount of very weird advertising that lands into your inbox, but automatically gets diverted into spam. And this is thanks to Gmail. It does make some mistakes sometimes when a client sends us an email and it lands in spam, but still, it's doing a very good job. And it's all because of the data that the users have fed in that provided this kind of training data. So this is a supervised model or application. The recommendation system for Amazon. I mean, we've all been there and we've seen that. Sometimes you just stop on your mobile. You don't click, you don't type, you don't comment, you just look at an advertising. And the second day, your screen is popping up similar advertisements. This is, again, part of the association rule, part of the, the clustering. So based on your similar behavior, based on your behavior, it will accumulate this data and then give you probable recommendation that you might like. Sometimes they do it right. Sometimes, they hit it right. Sometimes they don't. But again, they're doing good job. Another application of machine learning is social network analysis. And this is a real image of the SNA of the 9/11, the terrorist attack that happened. And this really shows the connection of all of the suspects that were investigated back then. This is a public image as well, published many years ago as a result of this investigation. It shows the intersection between the connection points between these and how it helped the investigators reach out to, the focal points and focal suspects within this investigation. Enough with machine learning. Let's talk a little bit about deep learning. And I can take a pause maybe for 1 minute here before carrying on. I don't know how much time we have, Howard. I don't want to. But again, we still have a couple of interesting items. Yeah.
Yeah, we've got 10 minutes left. So and that people tend to stay on a little bit longer, but maybe if we've got 5 minutes and then we can go into discussions.
Let me try to wrap this up quickly in terms of artificial neural networks and what do they do. And I'm gonna maybe try to narrow it down here using this one. When we say deep learning application using artificial neural network, it's just, and I will show you the simplest neural network that ever existed. I mean, here, this is, imagine you want to really predict if an interview should be offered to an applicant, okay? This is important for HR industry, for example. So usually what happens is that you get criteria and you get data points or attributes. So in this case, for example, you have a GPA, you have the years at school, you have the major, you have the extracurricular activities, and so on. The neural network usually, and using very complex mathematical operations, they kind of try to find some kind of relationships and associations between these. For example, it could create feature called achievement that is a combination of GPA, statistics, and extracurricular activity, and label it experience as well, skill set. And then based on these and the weightage and the domain expertise that is usually recommended, it could take a decision to say that, yes, we offer this guy an interview or no. And later we'll touch a little bit on the human aspect of that. But this is just to explain what does a neural network mean. It's really imitating how the human brain works, at least for a certain extent. And we have here what we call a hidden layer, and that's why it's a little bit more complex. They call it hidden layer because it's really hard to interpret what's going on due to the mathematical complexity. But again, it's another discussion for another time. And this is, I mean, a quote by Richard Feynman. I mean, why is it the simple abstract language of mathematics that could accurately capture so much of our infinitely complex world? And it is true, because at the end of the day, it's really amazing what mathematical formulas and models would be able to generate if really combined, coupled with powerful machine and computational power. In terms of deep learning applications, we have, I mean, discriminative and generative. And this is discriminative when we want to classify something, when we want to, you know, simply, and I'll show you as this example here, this is discriminative AI, okay? This is a machine learning application used on CCTV camera that could immediately detect the object, link it to the data that it trained on, and then decides what it is this. This is discrimination or discriminative machine learning. The generative is what is the whole fuzz about. And basically, it's about generating something new. It's about generating new content. And if you want to look at the applications of that, and this is what we did in the example of the juice and Orange County, we as human beings, we are generative by nature. We can create a new content. But the machine only recently was able to do so, such as ChatGPT. Some of the text analytics is an application of deep learning models and generative AI as well. So, for example, translation, text-to-text, speech-to-text, text-to-speech, chatbots, and finally, ChatGPT, which is very much human-like. And last but not least, I would like to get your opinion on that. Everybody, I'm sure, hates this, but please let me know, what do you think this is used for? I know a lot of people will be so upset when they see this, but let's figure out together, I mean, what is this really used for? We keep on having this whenever we want to log in or you know, try and register a new account. But really, why is it like that? Why isn't it a simple CAPTCHA like good old days? I mean, really, it was, I'm not a robot and I just check a box and that's it. I mean, I'm happy, I'm good to go. Image recognition, training, avoid cyber attacks, image recognition. Okay. Image recognition for what? I mean, what are we doing here? Apparently, we're trying to provide something for someone, but what are we doing really? I think I can hide this and it's still, if you still have it. I think an AI can trick it. Yeah, true. detecting if the response comes from a person. Yeah, but I mean, we could have done it simply with a checkbox or something. But anyway, I don't want to keep you too much waiting, and for the sake of time, this is actually being used. Someone came with a nice idea of leveraging our abilities to identify these images and provide input for self-driving cars. So what we're doing here, every time you get prompted with this and you do this, this data gets taken to algorithms that are working on that. And this, one more time, illustrates the fact that machines still needs loads of data to be trained eventually to be able to perform better. And to know more about this, really, you can reach the YouTube and can share the link afterwards. And there is a complete video about this. The man who invented this and had us all stuck with these annoying. Sometimes they don't work, and sometimes we fail on detecting the picture, and we have to do it once and again. And really, if we want to ask ourselves the question here, I mean, from my end, at least, I would think twice before jumping on a self-driving car, at least until I stop seeing such images, because I know then the model is ready. As long as we're training the model, I think it's not ready. So really, I don't know. It's up to you, but this is me. Ethics and risks. So are machine learning models always right? I will resort to this quote from a statistician. And I mean, all models are wrong, but some are useful. And this is a very strong statement by a statistician. And I will give an example, the financial crisis in the world, starting with the US. This was really an example of how these machine learning models failed to predict the risk that is happening. And if you want, you can watch the movie The Big Short. If you haven't do so, I would really recommend you to watch this movie. It explains what happened, and it shows how some data savvy people were able to figure out some of the patterns that were happening, and they leveraged this crisis to make billions of dollars. Some of the risks are the generative adversarial networks. So the GANs, these are used to create deep fakes, which is basically putting people's faces instead. For example, here, this is the real picture, Jack Nicholson, if you know the actor, and this is an image of Jim Carrey on this. And you could, I mean, if you don't know really, it would look very much credible. Same goes here, the real picture, and you could put Tom Cruise's face or vice versa. So the idea here is how dangerous this could be, and it's happening every day. Fake news, fake event. I mean, this is also something critical and going on. So really, it's about being careful not to get tricked by these new technologies. We wrap up with some maybe ethics considerations. I mean, really, what do we want AI to replace? This is a question that we want to ask. Or do we want really to use AI to have some kind of to judge a previous offender? I mean, really, it's about thinking which data we're dealing with. If we're dealing with people data, there's a big human aspect that we need to consider. The biased data, and I'll give a quick example afterwards. What does it mean that data is biased? And I mean, really, how does this affect the result of an algorithm? And the regulations and laws to stay on the right side of the law. And there are a lot of regulations nowadays really trying to govern AI, but in my opinion, they are still pretty much modest. And some examples of bias. For example, in I think a couple of years ago, there was an article published that says the US, I mean, there was a problem with the US facial recognition system that was used by the police. It turned out that the algorithm was detecting or identifying young female African-American citizens far more likely than any other group. And this is why, because simply the data that the algorithm has been trained on was more of data including African-American candidates. And this is an example of biased data. They did not take the whole picture. They did not include data from different races, different ethnicity, different backgrounds. They only had potential data. We're not saying that they did that on purpose. I don't know, but again, this is an example of how bias could creep in. Amazon as well had an issue, and these are the articles that are real. I mean, these are real examples of bad exercising of machine learning. And Amazon really they had a sexist job application solution that did not really disregarded female applicants. Why? Because it had only data of male applicants or more data of male applicants, so it failed in identifying a good female applicant. And it really stopped. I mean, there was some protest about that. I think, I mean, if the time does not allow, I still have a couple of slides, but we can really jump through. It's about the governance, Howard. It's about, you know, the organizations, how we could be. So it's up to you. Just let me know. We can stop here or we can proceed. I don't want to really keep everybody long.
Yeah, let's go through the last bit. I'm interested in understanding the governance. I hope everyone else is.
Okay. So that's it. It's just maybe 2 or 3 slides. So basically, AI and organizations. So I'll start with a quick introduction that big tech still have the upper hand, and we all agree on that. I mean, Google, Facebook, IBM, Microsoft. Why these guys are strong in terms of AI? Simply because they were quietly for years collecting, training data, and they had the opportunity to do so through their platforms. And we've seen Gmail is one example. Google search is one example, Microsoft Solutions is one example, and so on. So and of course Facebook. I mean, it's all around emotions, all around comments, all around interactions of people. So they still have the upper hand, and it's really all about the data. And this leads us to think a little bit on the transformation journey. And I would suggest, and I would like to share this with you, that I would always assume before talking about the AI transformation, you really have to go back to the initial thought of having a data first approach. And why I'm saying that, it's really, I'm depicting it within this triangle. I mean, you have the organization, you as an organization, regardless of your industry, whether you are in the energy sector, whether you are in the sustainability and environment sector, or whether you are in the IT, marketing, etc. You have a vision, you have a mission, you have a question, or a statement, what do I want to achieve? You have a business strategy. On top of that, and I'm going from bottom up, you have the data strategy. It should come, at least the way I see it, it should come before having an AI strategy. And a lot of our clients really that we work with, they sometimes bundle data and AI, which is fine as well. And there's a rising need for AI governance. And there are some kind of regulations happening in terms of, for example, in Saudi, Sadaya, this is the Saudi Data and AI Authority, they have published some guidelines. Still, in my opinion, very high level. It could be interpreted in many different ways, but I'm sure organizations are trying to adopt and maybe tailor it according to their work and industry. And the European nation, they also published the AI Act, what they call, and it's a set of principles as well. So maybe I would like to, again, ask you, what do you think, if you allow me here, what do you think the key aspects an organization would need for a successful AI transformation? I'm thinking from data first approach, if you want. I mean, this is what I would recommend, because many of the organizations still are far away from being really adopters of AI. And in order to do that, you need to start with the data, with your business data. So what do you think the key aspects, I mean, to have a successful transformation? Just share, I mean, your ideas. Trustworthy data, data management, governance, focus on quality data. Amazing, amazing. Okay, I mean, these 4 statements really tell a lot because, yeah, still understand their, okay. I think it's pretty much people, very good. Ethical data control, very good. And I can say that all of these answers are more or less, I mean, accurate in a way or another. And I would like to share maybe what I would usually suggest and recommend. Usually, we tell clients, companies, regardless of their industry and the size, to start with the attitude. I mean, if you recall back in the early 2000 up to 2010, it was all about digital transformation. It was the big hit. Everybody, I'm a digital transformation expert. I'm a digital transformation consultant. And it was the motto back then was every business is a technology business. And it was true. But nowadays, I would say that the motto has changed. And I'm sure you agree with me that every business is now a data business because technology is for granted. It's by default. Now, every business is a data business, regardless if what your service is around technology or no, you need data to be able to survive. And this is why the attitude is important. Creating a data culture is definitely important in terms of, and I think, Howard, in your previous conversation, we came up to that as well in terms of really the collaboration and the having a proper operating model. Then devising a data strategy. This is extremely important because you need to have a data strategy in place, a strategy, again, to at least guide you with where you are now, where you want to be, what are the use cases that you, and how to bridge in this gap. So having this as a foundation is crucial. And of course, embracing technology and investing in technology. And when we're saying embracing technology, not only tools and solutions, but also people and capabilities. And finally, I would share with you maybe this one. I will wrap up with this slide. I mean, everybody's now is trying to govern AI, and it's really something that we're hearing a lot about. And this is again an illustration that I would like to share with you. It doesn't mean that this is the only way to do it, but I try to depict it within a cycle of problem, plan, data, and this is where the intersection happens with the data governance that is now already starting to get mature in many of the countries. And then you have the deployment of the actual solution or the model, and eventually the conclusion. To be honest with you, I inspired this from the classical PPDAC cycle, which is in statistics, problem, plan, data, analysis, and conclusion. I changed analysis here to deployment, but eventually it's the same. And how to govern AI, it's really to think on what is the cycle that revolves around from end to end. And we usually start by the problem. I mean, what do we really want to achieve with AI? What are the ethical implementations? This is the problem statement that you start with. And then you put up the plan aligned with your strategy to achieve the use cases that were depicted in your data strategy initially, for example. And then there comes the data, which is the core component of any AI cycle. Because if your data is not governed, you cannot talk about AI governance. AI governance has specifics. But to me, at least to me, as a data consultant who has practiced many years working on data management and governance projects, I would say that maybe 70 to 80% of your AI governance is about your data governance. How you're collecting the data, your integrity and quality, like many of you have answered, management, governance, integrity, trustworthy data. Security and privacy, definitely in terms of your personal sensitive data. What are we talking about? What is the use case? So this is really the key aspect of governing this. And if you look at Sedaya's principles, they are more or less touching on these human aspects that we mentioned in terms of the ethics. Finally, the deployment, and there are a lot of ways, I mean, we could really discuss these later on, but there are ways in the hands of data scientists and AI practitioners to really make sure that there's no bias, or to minimize this bias, to make sure that they have really their data is really representative of the actual population they're dealing with in order to get better results. And of course, this is a cycle, so it comes back with new ideas, communication, and all. And I would also maybe share with you what Colibra has depicted. I mean, this is how they imagined an AI cycle or governance cycle by defining the use case, like we mentioned, identifying and understanding the data, documentation and explanation, and this is where the transparency of the model has to be there, and finally, the constant improvement or monitoring. And that's it. I mean, we're here just sharing a couple of ideas, really. What is the true value of AI? I mean, it's about sustainable cities, communities, quality education, good water sanitization, affordable. And these are use cases that could be applied, where AI could be applied. And these are inspired by Bernard Marr from his data strategy book. You can get the book and have a look at that, because I don't want you to think that this is more of an Oscar ceremony or Miss Universe speech, because these are really actual potential use cases that you could do. And really, that's the true value of why we should be creating value of the AI. And I will rest. I mean, I'm not gonna. That's it. I mean, we reached the end. I know I maybe have skimmed through some of the aspects quickly, but I'll leave it to you guys. If you have any question, if you have any points, discussions that you would like to have, I'm happy. I'm happy to stay.
Fantastic. Wassim, thank you very much. So maybe just to open it up, if you wouldn't mind putting your hands up. Great. So if there are any questions, I know there are a couple in the chat, but if there are any other questions.
I don't have access to the chat. I don't know.
Sorry. Oh, yeah, we both talked last time. Hey. Okay.
I'm using the same device. Yeah, so that's why.
Yeah. Okay. Anybody else before I go to the chat? Are there any questions? But the one question I know I had was some people. I thought when you mentioned narrow AI, I've heard some people call it shallow AI. I don't know if that's similar to narrow, and I'm not sure exactly what the difference is.
To be honest, I never heard the terminology shallow AI, but I'm assuming it's another terminology for narrow AI, which is what we're doing. And in the realm of AI, Howard, it is really what we're currently doing is still really shallow in terms of what could be done compared to the human brain. And that's why I really wanted to give this example. It's really still at the basics. But to note that it's advancing on an exponential rate. So after a couple of years where we are, I really don't know.
And I think I liked your one about in terms of intelligence. They had your brackets big data, and part of what that comment on shallow was is that up until now the amount of data has not been big enough to be able to address a lot of the learning that you're talking about, and available enough. So that was the predictions and the whatever it was doing was rather shallow compared to the deep type of learning we're getting now.
True.
So yes, Atindra has the hand up.
Yes, correct. I have a question. So, I mean, I know a lot of organizations are spending the effort in LLM and Gen AI kind of applications. Are there governments doing anything that are noteworthy? I'm from Singapore. I know Singapore is doing a couple of things. Singapore government has AI governance framework, and they have recently launched Project Moonshot. I mean, something like testing of LLM applications, something like that. So are there governments around the world also doing something about how to safely integrate Gen AI applications into practices?
Governance. You're talking about governance, right?
No, I'm talking about governments, countries around. Because I am from Singapore, and Singapore government itself is doing a lot of things to ensure that whatever is introduced in the public domain, they are safe, and Singapore government has an AI governance framework actually, and recently they launched another project actually, Project Moonshot, to test LLMs in a safe and secure manner, something like that. I don't know exactly what they're doing, but something they are doing actually. So I want to know: are there countries around the world they're also spending? Countries and governments, they are doing something to ensure that safety and security in this space actually.
That's an important question. Yeah, that's a very important question, Tindra. And to quickly answer you, yes, they are. And I gave an example. For example, in Saudi, Sadaya did published, and they had an event last week in Riyadh for AI specifically, and they published the guidelines in terms of AI. And they already have been working for years now in terms of the data. Because what you mentioned when you're talking about privacy, what privacy? We're talking about the data privacy. We're talking about personal information privacy. So yes, and there are some strict laws not only in Saudi, in the whole GCC region, because this is where I work. I can speak for that at least. But I know that in Europe, and they all have this kind of acts, laws. In my opinion, to quickly maybe tell you, still they are on a high level, still not being, how can I say, mandated. But we are on the way. And very soon, like we heard in Saudi, I'm sure Howard knows, like we heard in Saudi, in terms of everybody's doing now the data management office because they have to be compliant, they will start now doing AI governance and AI compliance to make sure that if they have applications being deployed, that these applications adhere to, I don't know, personal protection law or whatever. So yeah.
And just to help you there and support you, Wassim, the Ministry of Health has almost decreed that any form of AI, be it in a device, a mechanical device, or be it an algorithm, has to be tested within the test environment with certain test cases to ensure that it doesn't come up with wrong answers. So these ministries are actually establishing playgrounds and certifications to prevent AI from causing the problems that they shouldn't be causing. So they are very active in controlling the deployment of it within the entire health industry.
Yeah.
Caroline?
Hi guys. Yeah, thank you, Ibrahim. That was a very informative talk. I hope you can hear me okay.
Yes,
we can.
Okay. Just two things stood out to me as sort of if I think of the cluster of skills that you need to really get into AI, I'm thinking of future-proofing from an IT career perspective. The one side, when we look at the bias and the limited appreciation for the data sets that were selected initially. To me, that's kind of research skills, right? So that's kind of what you learn, when you get into a postgraduate degree, they'll teach you how to do research. And I'm wondering if IT skills needs to start including layers of research. I know the Sophia framework have research as a skill for IT. But something that stood out to me that was a bit surprising to me was the role of statistics. And I never really appreciated that before. So thank you for that. And I'm just wondering, is there like a idiot's guide to statistics for AI? Is there something we can latch on to for those of us who are a little bit challenged when it comes to things like that?
I'll give you a recommendation. Yeah.
Thanks. That's my question. Thank you.
Yeah. For the first part, I totally agree with you. And really, that's a good step that you're doing in terms of future-proofing the career. Everybody has to do that. Everybody needs to speak the data language and understand what does the data, mean, and how to manage this data, how to govern it. And yes, I agree with you. There should be some skills in terms of, you called it researching, but it's a matter of calling here, and this comes with your second question, because when you're really dealing with data, if you have the basic statistical knowledge to understand that is this data representing the overall population that I'm trying to mimic and try to solve a solution for, or no. And we've seen the example of the African American case in terms of the US police. They did not do this exercise. They had a lot, or they did not pay attention to this exercise because there was a lot of data. They did not maybe spend the time to really segregate and try to see if there are specific patterns that could cause bias creeping. So yes, this kind of awareness, you want to call it research skills, you want to call it investigating the data, this is crucial. And totally it has to be, and I agree with you, it has to be part of a data scientist work before taking the data and dealing with it. And there are, and to give you some good, some good news, there are ways now to detect bias within the data, and there are mechanisms and tools that you could use to have some kind of trade-off between the variance and the bias within the data. Because people usually, they try to narrow down their data to get more precision. But when they do that, they fall into the trap of bias. And I can elaborate on this maybe in another occasion. But what you're thinking of is accurate. In terms of statistics, you can maybe look up for the book. It's called Statistics Without Tears. I know it helped me. Start with this book because it has no math inside, but it really dives into the concepts in a very smooth way. Statistics Without Tears, a penguin book, and it has some kind of icons on top of it. So yeah, I think this is a good recommendation. Yes, Murtada.
Sorry, could I just ask Daan Steenkamp, Dr. Daan Steenkamp? Daan is an econometrician and a statistician, and we've had lots of discussions about stats and AI, and he loves this discussion. So Daan, you've been quiet. I've been surprised. Any comments from your side?
Hi, Diesel. Hi, Howard. Sorry, my camera's just not working.
No problem.
I think this was very interesting. I think we tend to build machine learning models for specific use cases, but I think my take on it is that we see the proliferation of and excitement of the use of these techniques, but I can't help but worry that unless you really understand what you're doing, you can get you can get misleading results. And we've certainly seen lots of clients be disappointed by the investments that they're making in AI or machine learning. And so I guess my take on it is that we need to be, as practitioners, I think there aren't shortcuts. And I worry about people promoting the idea of no code approaches to machine learning and doing things via shortcuts. I think, in my opinion, at least as a statistician, we need to make sure that when you apply a complex framework, you understand what you're doing. And so I think that in order to realize the tremendous potential of the things that you have discussed today, we really do need, as a community, we need to make sure that really high standards are promoted, so that clients understand the costs and benefits of using machine learning and AI.
It's a very, very important point that you raised, and allow me to mention something, and then we'll go to you, Murtada. You've been waiting for some while.
Yes.
Dan, this is totally accurate, and yes, there are a lot of disappointments, and yes, we spend a lot of time convincing the client that it's not a plug and play. You cannot just come and start predicting and magical things happen just because you have a little bit of data or you have the potential to buy a solution. And really, I would say something that maybe I wanted to share during the presentation, that AI, in my opinion, is overestimated on the short term, but it is totally underestimated on the long term. And this is where the fuzz, where the confusion is happening. No, we are overestimating it now. And yes, statistics is a crucial part, understanding what do we mean by that. And it all comes down to statistics. And that's why I use the example at the end. I'm not a statistician, definitely, but I mean, just to give you, an idea about this. So yes, I totally agree with this. And it is one of the major concerns, and awareness need to happen. I mean, similar sessions like this one need to happen for a lot of non-technical users to at least know where we still are and what lies still ahead in terms of transformation. Yes, Murtada, by the way, he's in. I know him. He's a guru in technology.
Oh, nice.
He's one of my ex-colleagues. Hi, Murtada.
Thanks, Wassim. Can you hear me well?
Yes, we can.
Okay. First of all, I don't know if you answered some parts of my question. Okay. But first of all, I want to thank you for the excellent session you did, Wassim. And I have anticipated more discussions about generative AI. That's why my question is about generative AI. And my question is really about if you foresee any limitations for this part. And years ago, we didn't expect social network and social media to have such a significant impact on our lives. Yes. But now we are overestimating AI, but later on it might do something like you said in your presentation. You said that a business without data maybe can have trouble nowadays. So how much you see AI or generative AI specifically will reshape our lives, and to what extent?
Yeah, it's a very good point. And I started my presentation, Murtada, by showing the impact of it. So these numbers would tell you immediately that, yes, it is reshaping, it is changing the way people work. And in terms of what you just mentioned, this really translates into what I just said, that yes, we are overestimating it on the short term, but we are underestimating it on the long term. And that's why there should be every business should be now adopting a data transformation, embracing technology, and starting with minimal use cases of AI adoption, whether it's a simple, classification, clustering, whether helping the HR selecting proper candidate, whether saving time on content creation like we do on ChatGPT, et cetera, et cetera, et cetera. But yes, it is definitely changing the way we work. It started already. The impact financially is huge, and I've shared the numbers with you at the beginning of the presentation. So now is the right time to embark on this journey. And I'm assuming that's why maybe you are attending this and other candidates are attending this. And you as a technology expert, this is even an easier transition towards this world. So yeah, I mean, to answer your question, it is definitely reshaping, and it has to be endorsed with proper attention to the limitations, to the actual ethics and risks that could happen, which we elaborated on. And yes, I did skip through some of the generative AI applications because we had to accommodate for the time. But I mean, we can have this conversation offline later on. I'm happy to do so.
And maybe just to the one revelation that came to me was similar to the way in which the pilots are being transitioned from, they call it fly-by-wire, and that's where they could move the joystick and it had a direct impact on the plane. Nowadays, that's going through a machine before that gets, so the machine is translating those instructions. Now, one of the things that I think about from a data governance point of view, when everything we're doing is policies and procedures and stuff like that, so basically, should that generative AI not be helping us where a steward or a citizen asks for data? Well, because the machine can read the policies and interpret it and act on their behalf in terms of the procedures, why can't we do data, in a similar way where generative AI guides us, controls us in terms of what we do according to policies and approaches that we have? So I think it's tremendous in terms of how we can improve our data management and rethink the way in which we do things.
Yeah, I totally agree.
Does that answer your question? Okay. Atindra, yes.
Sorry, I had another question actually. I mean, we talking about data biases in data, but another aspect, if I understand correctly, is for example, if you're using deep learning model, it's hard to explain why certain decisions were taken, or certain paths were chosen over others, right? I mean, why, let's say, why a certain thing has been classified the way it is. I mean, because of the huge amount of data and huge amount of paths it can take, right? And again, for Gen AI, it is all doing is predictions at the end, right? I mean, it's not, I mean, as a result of which you can still get wrong results. So my question is, I mean, are there any work happening to, I don't know, I mean, when you were talking about governance framework and things like that, it is very difficult to understand like why certain paths were taken, why certain results we got. And it could be erroneous, right? At the end of the day. And how do we really, today, I don't think there is a very good tool to arrive at the conclusion like whether the decision is right or wrong. But are there any works happening in this space, like to take care of this in the future, maybe?
Yeah, I think this is more or less, if I understood you properly, this is still within the same idea of having some kind of control on this whole cycle. And I mean, I'm gonna tell you that it's still very modest, for me at least, from what I observed. It's still very modest. And I'm sure you are all part of organizations, and every organization has published some internal AI policy or guidelines to use, or either they banned you from using ChatGPT or whatever. So it really depends on the organization. the problem here is that every organization has a different interpretation of how to really control this. And it really goes down to upper regulatory bodies and authorities to really depict this. And I know for a fact that Sadaya is on the right way. They started with these, but I've heard within, the corridors and the backgrounds that they are planning to start some heavy work on publishing more comprehensive AI governance frameworks, like they did with the data management framework that they've done. It's very comprehensive. It's one of the best that I've seen. It almost tells you how to breathe, when you're working with data. So it could be the same for AI. Still if I want to answer your question, we are still at the very beginning. Still, it's not unified, consolidated, or controlled 100%. So I totally agree with you. And we have to ask OpenAI, to be honest, to be more transparent what they're doing, because yes, still, we can get, if you don't ask ChatGPT about the reference, he will not share it with you. And sometimes when you ask him about the reference, you put him on the spot and he says, oh no, I just got this from best experiences. So really it's about going back to the actual who's overseeing this. So I agree with you. It is a worry, and we're all now starting to hear this. Now it will start to get regulated, hopefully.
Yeah.
Thank you.
Abi, your hand was up. Any comments from you, sir, or questions probably on risk?
Yeah, okay. Good afternoon, everyone. So I think you did touch on what I wanted to mention, but I'm happy to still contribute. It is more around internal organization on how they can utilize AI or generative AI for better managing their data. What I've picked is just some of the challenges that comes with using those AI, and I'm not an anti-AI person, but I'm just raising some of the risks that always one encounter, especially being able to understand how far the AI can go. Let's say if you want to use it to better make information available to all your users, be able to search the information in all different platforms. In some cases, I've seen that some of the AI tools get or retrieve information that can be even, sensitive information. So it also enforces you to start looking at that, classifying your documents, whether restricting that so that it can block some of that access. So it's one of these challenges that comes in, and now it forces organizations to start look deeper into how far can AI or generative AI or in terms of security breaches. One other comment that contribution that I want to make is just around as more countries are starting to publish discussion documents or even AI Act, like the UK one that they now make laws. So for instance, in South Africa, I know they are looking at the discussion document, but the enforcement of that, it's always a challenge where there are breaches of the policies. I've seen now, even locally in South Africa, where they raised one of the challenges in that some of the multinationals like your WhatsApp, Facebook, when they do breaches, it becomes a bit of a challenge either to enforce the policies, because they raise things like jurisdiction as one of the arguments. So it's still a complex subject, but I think it's maturing, similar to what your GDPR has matured to be, where it is able to enforce some of the penalties and all that. So yeah, that's all I wanted to contribute on. Thank you.
Yeah, thank you. Thank you so much. I think, it's a valid point. And the second point of your contribution, I think it comes down to exactly what we've been now discussing. Yes, it is very complex, at least at the moment, and nobody has a one answer in terms of governing and controlling all of these aspects of AI application. And for the first part that you mentioned in terms of your organization or any organization, I would always say that it's about starting with and this is why I have depicted this cycle. And it's all about what do you want to achieve. Start with a simple use case and see what does this would achieve. And is it really worth it that I use AI for that, or it could be done using other, less complicated, or I mean, sometimes we use the terminology AI and we get mixed up into, I wanted AI to do this, while you have a simple, straightforward software that is already there that could do the same thing without calling it AI. So it's really about understanding what you want to do, what do you want to achieve, and eventually starting with a pilot proof of concept and see how this goes without neglecting the implications that you just mentioned. But yes, I mean, thank you for it makes sense, definitely.
Fantastic. Wassim, I'd like to really thank you a lot. I think we half past, we 18:35, so we've gone way over. There seems lots and lots of questions, and I'm sure we could go on for quite some time. I'm sure Wassim would really appreciate if you contact him on LinkedIn, if we can start some of the discussions there. I'm sure Wassim will be happy to contribute. So if it's okay with you, unless someone's got a burning question, I'd like to bring it to a close so that people can get on with the things they need to do. And